Hi there, in this video I'll explain the mechanism of looping a sample in the Granular Oscillator as well as explaining the loop mode envelope. In the first part of this video, let's take a demo of this envelope. Firstly, I just point out that I'm using a start time of 100 to envelope and the time is set to 0 and we are enveloping the start position. So we have the ability to loop any section of the sample in any direction with independent looping speed, transition, as well as control over the preceding trigger section. We can create a granular loop to our samples with the loop envelope mode. Given the ability to assign macro controls to envelope breakpoints, we can determine where the loop occurs and how fast. Here's an example. To best use this envelope, the only requirement is to reset the sample duration to double that of the loaded sample. In this case, the sample is 4 seconds, so we simply apply 8. This is because the envelope breakpoints are using absolute time values. Although we can mix and match these controls to different sliders, I chose to have independent speed due to each envelope breakpoint only having one path. Time stretching therefore happens as attached to one breakpoint, or by one variable only. In other words, controlling the loop rate is only controlling the path of the final loop breakpoint, which can only be assigned once. This is available on my website if you'd like to use it. You can download both the preset patch, which contains all the information, as well as the oscillator template, except the oscillator template doesn't store the macro control names themselves. So now let's look at the envelope itself and break down how it's made. So the first breakpoint, which is actually the second, controls only the position of the start point, and the path itself is set to very narrow for the reasons that we can't assign the very first breakpoint. So we can just set the path to the minimum and then we control that start position. So the following breakpoint is assigned to the start time length, which is the length of the starting or the preceding sample. So when that's maximized, it just plays at the normal speed. And the amp assignment is the loop start. So since the path is linked, that means that wherever the sample finishes playing, it's automatically going to join to the loop section of the sample. That does also mean though that if the loop start and the sample start are set to the same position, then we don't need the start time to play, so we'll just retain only the loop itself by minimizing the start time. The next breakpoint has the loop start marker attached, which is also joined to the blue path, which is the transition time, and that is also assigned to the loop start value. So the loop start value determines the position in the sample, whereas the transition time is the time it takes to lead up to that point. I'll demonstrate this as well in a second, but basically once the loop reaches the endpoint, it also can be reversed in a transition time back to the beginning. You can see on this envelope that the maximum value is actually the same length as the sample. If I wanted to have just the sample looping in one direction, then I can just minimize the transition time completely. So the next marker is the loop endpoint. And the macro control also controls its associated time, which is the loop rate itself. It can be shrunk to 95% shorter, otherwise which it doesn't work very well, and I wouldn't recommend using the granular mode in very fast looping anyway. Given that it is only a straight line, this is very simple, but if you would like to create a complex loop, you can draw your own pattern by creating breakpoints between these two red markers. Lastly, it is possible to create a release loop once the key is released. That's not really customized at the moment, and there is additional pitch bend macro here. Now I'm just going to demo this loop function with a sample that I have, which is actually just a pitch rising. It illustrates well the increase of pitch over time and what the envelope does to the sample. The sample is about 3 seconds long, so I'll just scale this to 6 seconds.